Hi, I'm Alessandro, and I'm going to show you, I'm going to start a problem that we were assigned of rational functions. Okay, so here we have our problem, and the first step is going to be to factorize the equation. So I'm going to start first step, and I'm going to factorize this, and the topmost equation is going to be 3x minus 2 times 2x plus 3, and that's going to give us this equation. And the equation of the bottom is going to be x minus 2 times 3x minus 2. So now the next step is going to be to cancel the terms that are repeated. Okay, so now we 3x minus 2 times 2x plus 3 divided by x minus 2 times 3x minus 2, and we cancel this one and this one. Okay, so now we are left with 2x plus 3 divided by x minus 2. So we're going to find the whole, and to find the whole of the graph, we are going to take this equation, 2x plus 3 equals 0, and we're going to find the x. So it's going to be x equals 3 divided by 2, and that's going to be our whole. It's going in this x. Okay, so now we're going to find the y, and to find the y, we're going to grab the whole this whole term. So 2x plus 3 divided by x minus 2, and we're going to substitute the x with 3 divided by 2. So it's going to be 6 divided by 2 plus 3 divided by 3 divided by 2 minus 2. Okay, so that's going to give us minus 12. So that's the number of the y, because we're substituting the x, right? So the coordinates for the whole is going to be 1.5 and minus 12. That's going to be the coordinates. Okay?
Hello, my name is Fernando, and now I am going to explain how to get the y-intercept and the a, the b, the n, the m, and the y. As you have seen previously, this is the original operation, and that's how you factorize it. We are going to use this factorized form in all the continuing procedure. To get the a, the b, the n, the m, and the y, we need to do the following. Here I have it, so you know it, but I am going to show how you get it. To get the a, you need to see the lowest exponent in the top part of the division and see the number that is beside it. Here is a 1 and the number beside is a 2. So a equal 2. A equal 2. With the b is the same but in the lower part. Here we got x, x1, there's nothing, so it means there's a 1, an imaginary 1 there, so it is b equal 1. The n and the m is the greater exponent, m of the part above and m in the part below. In both there is 1, here it is, 2. With the b is the same but in the lower part. Here we got x, x1. There's nothing, so it means there's a 1, an imaginary 1 there, so it is b equal 1. The n on the m is the greater exponent, m of the part above and m in the part below. In both there is 1, here it is. So it is n equal 1 and m equal 1. You use the n and the m to get how will be the horizontal line. In this case here I got examples of the 3 ways it can be. N is less than m, n is equal to m, and n is greater than m. In this case, n and m are the same. So, m are the 1. So, it is now a division of a and b. A is 2, b is 1, 2 over 1 is 2, and the horizontal line will be in the 0, y2. And that's how this part is done. Getting the y-intercept in this problem is similar in the other problems, because we take the 2x plus 3 and we pass down 2x plus 3 x minus 2. I will use purple to solve this because it's easier to see. We just substitute x to 0 and we make 2 0 in a parentheses plus 3 over 0 minus 2, and we just solve it. 2 times 0 equals 0 plus 3 equals 3. 0 minus 2 equals negative 2. And with this, we just get the y-intercept. It's easy. It's 3 halves.
To finish our equation, we will need to do a graph. So we have that y is equal to negative 1.5. So we place negative 1.5, which is our horizontal asymptote. So we'll place it in here, just as I did. And that will be y negative 1.5. Then we have that x equals 2, so we come over here, and y equals 2, we go here. Here is our 1 point. Then our whole number, since negative 1.5 is also x, we will need to eliminate our vertical line and place a whole number. So in order to make our graph, we'll need to, you can find more points substituting any number after your horizontal or vertical line. And we finish.